Very good evening, Bonada. I'm Professor P. Jagadeeswara Rao. Of course, I'm not having a background of agriculture altogether, but I carried out a couple of works related to agriculture with the help of my student, and then we submitted the papers at international level conferences. Some of the papers have been selected as best papers, and I will try to showcase at least one paper which was selected for international conference where I was presented personally at Kyoto, Japan. Well, so this is the outline of my talk. I will try to introduce about remote sensing. Probably you're all using the remote sensing by this time, and some of you are maybe good in remote sensing. I don't know, but still I will try to give a glimpse about the remote sensing. And then nowadays, without remote sensing, satellite images and geospatial technologies, if you talk 100 things also, nobody will not listen. You have to give a satellite data proof, otherwise people will not believe. In what way it is, I will also try to give some kind of presentation to you. And then with regard to other things, GIS and then related terms, and then integrating data with GIS and other things I will try to show you in this particular talk. Now, we are all aware we are sending very costly satellites to the space. What for? This is really a $1 million question. Why can't we do it manually that we were doing for the last several hundreds of years or several decades? What was the wrong in that? And how best we can eliminate certain errors with the help of satellite technology? That's the question. Now, what exactly is remote sensing? I am taking you all to the space. Right now we are talking about different agricultural activities. I was also with you from the morning till now. Fantastic discussions, of course. But I will take you to the space. Let us enjoy the space. Okay, I will safely return you all to the earth. And then what exactly is remote sensing? Of course, God has blessed each citizen, each person with beautiful eyes. When you look at a particular object, it is just because of light reflection, light mechanism is the particular parameter wherein some kind of physics and chemistry takes place on the particular object. As a result, you can able to see the particular object. So when you observe certain things or a phenomenon from a distance, it is simply known as a remote sensing. It is simply how our eyes are functioning in the similar way, how our ordinary camera is functioning and what principle it is functioning in the similar way. Satellite images are also acquiring data from such a great height like 700 to 1000 kilometers, even 36,000 kilometers too. Now, we talk about several remote sensing systems. For instance, active and passive remote sensing on the basis of source of energy is concerned. For instance, passive remote sensing. For example, if you close your eyelids, you can't able to see. Though you are in the daytime, though you are under very scorching heat, but you can't able to see. Why? Because you have simply closed your eyelids. Okay, because light is not enter into your eye and you can't able to see, though the objects are just in front of you, because light is not entering into your eye from the particular object. Therefore, you can't able to identify that particular object. So, passive remote sensing are some of the examples are here: human eye, camera and radiometer. And then active remote sensing, some of the examples are radar, sonar and laser. I will try to give you a small gist about this. Now, camera, you take a photograph of camera with the agriculture field area, for instance. You can be able to understand what is the phenological changes, what is the growth pattern, what is the pest affected rate of the extent of pest affected to the particular agriculture area. Also you can able to understand that. But there are certain advantages with the help of LiDAR. You might have heard about LiDAR, laser technology. So if the laser technology beams on the particular object, you can able to see the girth of the particular plant also, canopy of the plant also can be easily assessed. There are several parameters are there, advantages are there with regard to this. When we talk about light entering on the screen, therefore you can able to read it, otherwise you can't able to read it, isn't it? So the same light is again coming back and then reaching to your eye, therefore you can able to read this is a wave theory and that is moving. Okay, this is a electromagnetic energy. So the sun radiation or even this bulb radiation also, it is a part in the electromagnetic radiation. Electromagnetic means electric and magnetic fields, both are perpendicular to each other and then perpendicular to the direction of propagation. So it travels at the velocity of light. That means 3 into 10 to the power of 8 meters per second. Now this is a electromagnetic spectrum. In the entire electromagnetic spectrum we studied cosmic rays are there, gamma rays are there, X-rays are there, this and that rays are there. Of course. Okay? Yeah, sorry. Yeah. Only a small portion in the entire electromagnetic energy is a visible region. Often we used to see the doctor. Doctor prescribes us, better you take a chest X-ray. Okay, we go for the chest X-ray. Can we able to see the X-ray and rays that is coming and incident on our chest? No, we can't able to see. Our eye is opaque in the particular wavelength regions. Our eye can able is visible or transmissive only this particular visible region. Rest of this region and other region, our eye is opaque. But I will show you how vegetation is playing an important role other than the visible region. This you can see, human eye has a fantastic advantage with regard to other animals as far as my knowledge is concerned. Because when we talk about visible region, again it is divided into 3 primary colors, blue, green, red. Its wavelengths are given here. This you can also compare with regard to Vibgyor. Okay. So the same blue, green, red again further subdivided into Vibgyor. Again subtract to secondary colors. Okay. Yellow, cyan, magenta also. So when you process these primary colors, a secondary colors also plays in the where the particular dye is required. This is what exactly the color mechanism, and then the remote sensing is taking other than the human visible region, that means near infrared, middle infrared, thermal and then microwave region we are harnessing for acquiring information related to a particular objects or a phenomenon or vegetation as well. This is what the simplest schematic diagram of the particular electromagnetic spectrum. So different kind of things, as I mentioned already now, X-rays, and then this is ultraviolet radiation. Generally doctors prescribes better you apply some cream onto your skin, otherwise there is a sunburn or something, some kind of problem will arise to our skin. And then we use the microwave and radio waves, etc. These are all different wavelengths. There is an applications, but we use only a limited portion of electromagnetic energy for acquiring satellite data. Now when we use the word satellite technology, our ordinary eye or even your camera all together work on the same principle. When light is coming from the sun, it incident on different objects, reflects back its own component of energy to the satellite. It means that there are certain physics and chemistry is going on. What kind of physics and chemistry? I will show you in some other slides with regard to vegetation, and then you can able to understand. This we used to talk about the spectral signature of the particular object. So there are teak plantation is there here. All the teak plantation, maybe species wise it is the same plant, but the crop growth pattern and other starvation with regard to some elements or deficit of water, whatsoever it may be, the growth pattern may not be same. Some plants may be dwarf, some plants may be gigantic. So those kind of things also can be able to identify on the satellite image because it has its own spectral signature. It will be recorded with regard to its reflectance energy on the satellite image. On the basis of that, you can able to identify plant canopy and then health of the plant and then extent of the plant and the depth of the particular plant also can be able to identify it. Now this is what exactly why we used to go for remote sensing from space. You just go through it, and of course I have a lot of Altogether I have a 95. If you can bear me, I will run through some of the slides little bit quickly. I will not create any bore to you, but you have to bear, there is no other way around. Okay, but why we used to take photographs, satellite images from the space? This is really a $1 million question. I will come back again with this kind of questions, and then I will try to give you solve your doubts also. In the meanwhile, you just go through it. So this is what exactly, then another one. Okay, so well, just go through it, and then this is also in continuation of that. But now I will try to explain now what exactly. This is the first figure you have seen already. This is the satellite image. This is also satellite image. Please try to understand this. This is a false color composite. We use the word false color composite. This is also a satellite image, but depicted in black and white. Okay. So all the objects on the earth is recorded with regard to two colors, black and white. Of course, different gray shades are also there. But the data will be there in soft copy, and you can process this data with the help of computers. So satellite is acquiring information other than human visible region, but that amount of energy or information is converted into human readable format or computer readable format. Otherwise you can't make use it. This is the secrecy in this particular one. Okay. Finally, you have to go for some kind of extraction of information using this particular satellite, and this is the output from this particular satellite image. How we can derive some kind of output? We are bringing land to the laboratory. Try to understand this. Okay, if you take a photograph, okay, of a particular agricultural field, so you are bringing agricultural status on the particular point of time to the laboratory to study further on the particular aspect. Similarly, it is not just related to a particular small patch of area. It covers large area, and then you are bringing land. One record, multi-read. For example, if you are an agricultural specialist or forestry or soil scientist or hydrologist or geologist or blah blah, everybody can be able to use the same satellite image for extracting information related to your domain is concerned. This is what exactly the case it is. Now, why is remote sensing useful? So large regions can be observed over time. You see here, sometimes if you switch on BBC News, CNN, 24/7 channels, at the end of this news, there is a one person all of a sudden enter, and he will simply touch screen. Okay, he will push that entire globe, one side to the other side, top to bottom also. He will show you, Tokyo receiving some kind of heat wave, or Washington is experiencing some rainfall, etc. So with some kind of animation also. How they are getting such a huge amount of information? It is just because of satellites. Satellites are disseminating or pumping data to the ground station, and it is directly connected to all the TV channels. There are certain experts, they can analyze the particular data, and then in turn they can disseminate the data to the users. This is what exactly is. See, global coverage is possible. When you stand at the top of the terrace, you can able to see a large area. If you stand in a particular room, you can able to see only this extent. So your vantage point will increase. This is what exactly the advantage. So you can cover with the help of satellite images, a global coverage, synaptic view, and then repeatability. Every satellite is not a stationary one. It is a moving object. It comes back with a particular known time period. So what was the change within this particular time period also you can able to record it. This is the advantage with regard to agriculture is concerned. Why? Because if you go for Kharif, for example, in the month of June or July, so when the satellite comes back on the same area in the month of August, what was the status of agriculture regarding the particular crop is concerned in a particular mandal? You can able to see that. So that is what exactly the advantage of that. So repeatability is there. So here there is a flooding is there. If you are expert, then you can able to see this. This is the flooding, extent of the flooding. Initially maybe cost, because satellite fabrication and launching a satellite costs nearly hundreds of crores. I do accept that. But when you are using continuously for a period of 5 years or 7 years or something like that, then it is quite cheaper in comparison to your manual service. Now, when we use the word remote sensing, there are several platforms are there. Of course, ground-based platform. Of course, I don't know how many among you are aware about this. There are certain radiometers are there, ground truth radiometers. That means it was already simulated paddy in the month of June, in the month of July, in the month of August, up to senescence, for instance. What was its reflectance characters? With the help of this particular wavelength, it was already recorded. And then a curve is developed. The curve, if I give a particular printing, then it gives the final false color composite. This is, you did not send a satellite to the space, but it covers a large area. That is the added advantage from here. You can understand this. Now, there are certain ground truth. This is a platform. I mean, you can carry on your hand also. It's possible. And then this is a truck mounted ground truth radiometer. And then this is Challenger. If quite few days, it will move in the particular orbit and then return back to Earth. And then these are the satellites, of course. Space shuttle satellites. Now, there are four fundamental principles are there. One is a spatial region. I will start from here. Spatial resolution. My eye is somehow poor. It can't able to identify, can't able to read ICRISAT on the particular board. That is the reason why doctors prescribed me to wear these particular spectacles with a particular power. Otherwise, I can't able to read it. Spatial resolution in the sense, you are all aware about the Google map. You can able to identify your own home on the Google map. That Google satellite acquired your home from a great height like 700 to 1000 kilometers. Believe me, it is simply a quantum jump in the space technology is concerned. So everybody, then it started creeping to the common man level also. So you need not be an expert. You need not be a remote sensing expert. If you are a common man also can able to see this. And there are so many other apps are also given in the particular one, so that you can make your distances measurement and other things are also there. Then what exactly spatial resolution means? Higher spatial resolution is good for certain applications, and then coarse resolution is good for certain applications. If you ask to submit your information related to agriculture of this particular financial year to the Ministry of Agriculture or to the Ministry of Finance, and how you will proceed? Such a great country covers several square kilometers, millions of square kilometers. How is it possible? By just removing all this cumbersome analog data and then analyze, see it and then draw it. Is it possible? No, it's not possible. You have to collect satellite image, apply a particular algorithm, and that algorithm will give you some kind of output through which you can able to infer the particular period year, financial year, India is covered with this kind of plantation, and then it is going to give this much output also. This is what exactly the input we are giving to the Ministry of Finance. For every fortnight, we are releasing one bulletin with regard to agriculture is concerned, and that basing on that particular bulletin, the Ministry of Finance or Ministry of Agriculture, they put that particular one as one of the table agendas in the Parliament or even in the Assembly too. So this is what spatial resolution is, a clarity or a small. For instance, I can give you one example. If you buy 10 megapixel camera from the market, because 16 megapixel camera is also available. 16 megapixel costs about 10,000 and then your 10 megapixel costs only 5,000. So to reduce the cost, you can prefer to buy only a 10 megapixel, which will not give a subtle difference in the particular object. Whereas if you buy a 16 megapixel, it gives you more clarity. So here also it is the same, that the back end of the electronics is only a charged coupled devices. It's a linear array of arrangement of the charged coupled devices, which has a residence time and reflects that particular energy will be recorded in a clarity way, so that your satellite figure gives you more clarity. So this is how it is happening. So there are certain, I will show you some photographs also so that you can able to understand this. So this is one simple example. You see here, this is a radiometric resolution. Okay. Now you see here 8-bit data. That means 2 to the power of 8. That means 256 gray shades. Okay. Now that is much clarity one in comparison to this 1-bit data. See this, there it is only white and black is used. Okay, 2 colors. 1 bit means 1 to power of 2. That means 2 only. It's a 2 shades. And but the 2 to power of 8 means 256 shades. So gray shades is differentiated 0 to 255. 0 is black, 255 is white. Okay. So on the basis of amount of energy that is reflected from this particular object, the energy will be discretized into 0 to 255. It need not be exactly 0, it need not be exactly 255 also. If at all it is a 255, it would be a white. If at all it is a 0, it is a black. Okay. So this is what radiometric, we use the word radiometric resolutions it is. Spatial resolution, radiometric resolution also. Yeah, please. Yeah, it is true, you are right. Probably you are assuming that this is a mistake. Okay, that's the reason why. No, it's not like that. There is no power in this particular one. Whereas this is the power, 2 to power of 4 is 16. But here there is no 4 bit, that is not with regard to power. It is only a 4 bit. That is the reason why 4 gray shades, simply 4 gray shades. People may confuse with regard to this mathematics is concerned, but here there is no major mathematics are involved. Only 4 gray shades, that's all. Now, when we use, see, there is an enormous amount of flora is there on these 2 satellite images. Can you able to identify this? Yeah, it is a black and white, fine, but still there is a lot of vegetation is there. As a common man, my interest is only to how much vegetation is there in the particular given area, that's all. Rest of other things I am not interested. But thematic TM band, thematic mapper band 3 red, thematic map band 4 near infrared. See, our eye is opaque other than visible region. Satellite sensors, one kind of cameras can able to record the reflected energy even from the other than human visible region. That is the beauty in the remote sensing. You got my point? So this is what exactly the case. That means our eye can't able to separate blue, green, red. The combination you can able to see it. But the technology can able to separate blue, green, red, near infrared, etc. Certain bands are good for certain applications. Please, I will show you that also. You see here now. The band 1, 0.45 micrometer to 0.52, and then the band 4 is infrared band, where you can able to see vegetation. And certain bands you can able to see, that band you can able to see vegetation and then water too, like this. This is a vegetation, this is all water. Okay, this is the variation with regard to band data is also concerned. When we use the word band, as I mentioned already that 2 to power of 8 or 4 bit data, etc. It is all, even our photo also. You take a photograph with your ordinary camera and then put it in the any software, zoom in. What happens? Finally it ends up with some kind of pixel. Okay. So this is also satellite image is also pixel. So satellite image is also matrix of numbers. So that means each pixel, that is a pixel, no? This is a pixel, no? This is a grid related to this, and each grid, gray color, white color, and some gray color, and then black, etc. is related to the amount of energy that is reflected from the pixel of the ground is recorded here. So when I give an input for my printing process, it gives a color emulsion like this, it gives you a beautiful photo. You got my point? This is how it happens. Now see this, spectral resolution is concerned, this entire blue, green, red is recorded with only one band, black and white. So that is the reason why she is looking like a black and white. Now see this, the same lady is appearing with 3 primary colors. It's a normal color photograph. Blue, green, red. So that means there are 3 filters are there. 3 filters are there, separated. When you overlap it, you will get a color photograph. The same you can also see with a one gray color. That means black and white. Now this is with regard to spectral resolution, blue, green, red. See this on the back side, this one. If you separate it, it appears to be to your eyes like a black and white only. As I mentioned earlier case, same here also it is the same case. It is also same. Near infrared and middle infrared, it is also appears with some kind of black and white. And when you merge these kind of things, you will get a false color composite or color product it is. Now this is also thermal. Thermal energy, believe me, very, very important, even for the agriculture also. When you go for too much forest area, I just experienced with some kind of cool climatic conditions. Okay. Similarly, is it cool throughout the day? Probably. Some heat it may generate, or the diurnal temperature changes may not be same. Daytime and nighttime may not be same. So even with the help of thermal data, you can able to differentiate different crops also, please. This is what exactly people are not touching this kind of wavelength region, but very, very good. This is the application of this, and what kind of maximum water penetration, vegetation versus soil, deciduous forest to coniferous, and plant vigor. This is more important. I will show you what exactly a plant vigor in the coming slides. But these are all some of the important applications, even with the help of band data also. Please try to understand this. Now, we have a different type of satellites. Okay. Not that only one remote sensing satellite. Sometimes, how you are making use your cell phone, how you are browsing different websites through internet, how you are going for reservation of your air ticket or rail ticket. It is all just because there are certain portals are there where you are entering and then you are going for reservation. Okay. This is all happening through satellites. If there are no satellites, communication satellites, you can't able to make use of all this particular kind of technology. So every individual nowadays connected through satellite, because nobody is not willing to forego or leave the satellite. There are people are saying that if there is no Wi-Fi also, nobody will not bother. If there is no cell phone, people will bother about it because it contains a lot of cell numbers. This is what exactly the case it is. So the reason is knowledge is power. Knowledge is power. There are so many number of cell phone numbers are there that people can able to communicate. Say all the time people use it to talk with some other fellows and then hey, how are you, and this kind of stuff is always there. This is one such a satellite wherein it will be sent to the space to the height about 36,000 kilometers. It covers hemispheric coverage and then its rotation is synchronized to the rotation of the earth. Therefore, it is called as a geostationary satellite or communication satellite, environmental satellite. It gives you information related to your cloud pattern, cloud movement and rainfall precipitation. One of the major inputs for your agricultural activities. When there is no rainfall, there is no agricultural activity in total, isn't it? And then there are certain sun synchronous satellites. This is a parallel to the equator, and then sun synchronous is perpendicular to the equator. Okay, that starts from pole to pole. This is the dotted line, pole to pole, and this is parallel to the equator. This is almost 36,000 kilometers, and this is only 200 to 1000 kilometers height. All our IRS, Indian remote sensing satellites, generally we use to launch to the height about 700 to 900 kilometers. And the examples are given here. And then satellite orbit determines what part of the globe can be viewed. This is what exactly. As I told you already that it covers hemispheric coverage. That means 3/4 of the globe will be viewed at a time. Within the gap of half an hour, data will be sent to the ground station also, so that the cloud pattern can be visualized or monitored, and it will be flashed that information to the aviation people so that they can plan for their aviation activities. And then size of the field of view, how often the satellite can revisit the same place. This is what exactly the case it is. And then length of the time of the satellite is on the sunny side of the planet. And similarly, images serve as a base map. When we are using the archival data, see, when you are at 10 years old, you take a photograph. How you looks like, it tells you. When you become 25 years old, you take a photograph for every birthday. You keep a record. It is an archival data. So whenever you have a leisure time, open this album and look that particular album. How I looks like when I was at 10 years old. How I looks like when I was at 25 years old. It gives you some kind of transformation in your body physiology or body morphology. Sometimes you may be happy for that or you may be bad about that. But this is also same. Images serves as a base map. See, it is something like a feature to object identification. Earlier we used to identify a feature. A river is a feature. A vegetation or forest is a feature. Now in place of that river and then forest, you can able to identify an individual forest species. This is the beauty of this particular technology. As in the case of Google Map, how you can able to identify your own home on the satellite image, in the similar way, you can able to identify individual plant species because of quantum jump in the spatial resolution. And then observe or measure properties or conditions of the land, oceans and atmosphere. We are talking about only just land and then agricultural practices. What about the rest of other things? When there is no soil is inert, for instance, soil is not responding to any of our agricultural activity, what you will do then? How you will produce food and fiber? Maybe in the laboratories to a certain extent, but that will not be the permanent solution. You can't be able to manage such a huge number of 7 billion people all over the world. Then how you can manage food and fiber to provide animals and then human life? Then that is the reason we are sending satellites to the moon and then Mars. There is a alternative habitable places or some other resources you have to procure by some other means to manage our human folk here in our in the world. So, and then we are also very much interested to see the dynamics that are there on the particular ocean and then atmosphere, because there is a reinforce. When there is a ocean dynamics are there, then there is a possibility of to precipitate of rainfall with an intensity of this much. Okay. So that again it comes again back to your agriculture domain or soil erosion domain, for instance. Okay. So this is how you have to have some kind of integrated approach, and then you should have some kind of idea how best these kind of things are taking place, and in turn how you can make use your agricultural activity, etc., etc. Map spatial distribution of features. We use the word features. Earlier we used to a different kind of entity, but now we are using only a feature or an object, for example. Record spatial changes. This is very important, as I mentioned that when you are at 5 years old and then 25 years old, how it is changing. Similarly, change detection analysis. We use the word spatial change detection analysis. In the year 1950, Hyderabad is not like this. But in the year 2013, Hyderabad is expanded to 1000 square kilometer area, for instance. See, there is a lot of change. In which side Hyderabad is developing or progressing, you can able to see with the help of satellite images. I can give you so many examples, but it takes a lot of time. This is the what exactly the satellite image. Believe me this. Can you able to see some kind of vegetal matter? They see that vegetation is not recorded on the satellite image with a true color or green color. I will tell you that in why it is recorded with a dark red color. I will tell you that. But just see this. Is it a vegetation material or something else? Yes, obviously it is a vegetation. Now, approximately 70% of the land surface is covered with vegetation. But everybody is worried about India in present statistics. We are just revealing that FSI, Forest Survey of India, is just given a statistics that India is covered with only 21% land is under forest. We are worried about that. It is supposed to be at least 33%. In fact, instead, we are having only 21%. That is the reason why most of the reservoirs and then surface water bodies are getting silted up. There is a lot of soil erosion. Okay, this is what exactly the case it is. But 70% of the land surface covered with vegetation. What kind of vegetation it is? Can we able to identify a roadside avenue plantation also through the satellite image? Yes, we can able to do that. We carried out that work. I will show you that. I will showcase you some of these particular activities. Vegetation is one of the most important components of ecosystem. We are all aware about that. And the knowledge about vegetation species and community developed distribution patterns, alterations in vegetation phenological cycles, and modifications in the plant physiology and morphology provide valuable insight into the climatic, edaphic, and geologic and physiographic characteristics of an area. See, that's what exactly I am telling about an integrated approach. You should have to have some idea about the rest of other domains also. Otherwise, you may not be able to understand what is exactly happening, what was the real causative parameter, and how you can understand that, how you throw a light on that, and how you to derive some kind of conclusion out of this. This is what exactly is. Yeah, temporal resolution. 4 spatial resolutions are there. One is spatial resolution, talks about the clarity of the photograph. That means 1 meter resolution to 79 meter resolution. That means 79 meter by 79 meter pixel dimension. It covers a feature rather than an object. If at all it comes down to 1 meter by 1 meter, then it is identifies your car or your two-wheeler also that is parked in front of your home. Okay, this is object identification is possible because of the spatial resolution change. Okay, because of higher spatial resolution, you can able to see this particular satellite with a canopy of the plant. But if the same satellite image is recorded with 79 meter by 79 meter, probably altogether this entire satellite image covers only 79 meter by 79 meters. Then automatically it comes down. You cannot able to identify each plant species. That's what exactly the beauty of this. Earlier that is not the scenario. Because of certain improvements in the electronics, and then we can able to improve certain things through which you can able to identify single plant species also. I will come down again those kind of things also. Now, again, when you talk about vegetation, when you talk about remote sensing, there are 4 important parameters generally can take place. Okay, what exactly it is? When light incident on a particular plant, okay, then that is what exactly incident. Okay, this is the one. It is coming from the solar radiation. Then it is reflecting. R stands for reflecting, with the same incident angle into the atmosphere again back, and then there is a transmission, and then there is an absorption. There is a transmission, there is an absorption. So all this kind of 4 or 5 kind of physics or chemistry, you can say otherwise, takes place within the vegetal material, and subsequently it sends its own component of electromagnetic energy. Why everybody is not looking same? Some people are white in color, some people are dark in color. Why? Because our body is reflecting that amount of energy to your naked eye. Why this room is looking like this kind of color? It is just because other colors being absorbed by this particular screen, and it is reflecting only this amount of electromagnetic color to our eye, so that you can able to see only that with that particular characteristic color, not even with any other color. This is what exactly the case it is. Now see this same one, or this is what exactly it is. Blue, red, etc. or infrared is reflecting back, and I will come back again. This is what exactly the canopy of the plant exactly. Now why vegetation appears to our eye as green in color? That's the question now. Now you see here, as I mentioned that 0.4 to 0.7 micrometer, it comes exactly like this, Okay, now what happened is, how much amount of reflectance is there? It is hardly less than 20. So it's a feeble energy, it is reflecting into the atmosphere. Can we, this energy can be recorded by the satellites? No, it's not possible. You have to improve the signal gain. Then only it can able to record. Otherwise it can't able to record. Now, but the question is, you see here, I'll show you a little bit detailed about this in the next slide. This is a soil and this is a water. Okay. I'll come back again with the spectral signature of this thing. But it is why? Vegetation. As I mentioned already that reflection, refraction, transmission, absorption, all this kind of mechanism generally occurs. It's not just simply by saying like that. It's not like theoretical part, because a mesophilic structure, there are some kind of air cavities are there, cuticles and upper dermis and lower dermis, etc. are there. And then when light incident on this particular one, it enters into the particular leaf, and then because of change in the vacuum, and it also redirects into the other directions, and finally it will be modified. It sends its own component of electromagnetic energy into the atmosphere. That energy will be recorded by the sensors. Okay, this is what exactly, you're all familiar with this. Of course, this is also. Okay, but yeah, photosynthesis, I need not explain anything for you all, because you're all good in this. So I'm skipping this simply. Well, with regard to this, you see now, this energy, anyway, here it is a 0.1 and something like vertical scale it is given. But why vegetation appears green to our naked eye means it absorbs blue and red color, reflects only green in the visible region. Therefore, the vegetation appears green to our naked eye. Got my point? There are certain plants are there. For example, chlorophyll alpha or A otherwise at this much wavelength, and then chlorophyll beta or B at this particular wavelength. Green is at 0.54. That means maximum reflection is there, a peak is there here. There are certain two values are there. Value is absorbs, peak is reflection maximum. But this amount of small reflection is not useful to detect the vegetal characters by the sensor. The sensor is kept at a height about 700 kilometers. So this energy, feeble energy, can't reach to the particular sensor. Therefore, this energy, that means infrared energy, is good for record the characteristics of the vegetation. Therefore, it is recorded with a red color signature. So that is the reason why vegetation appears on satellite image false color composite with a red tone, not with an ordinary green tone. This is a normal photograph and this is the same area with a red photograph. Okay, this is what I get. It is just because of chlorophyll or leaf pigments. It is just because of cell structure where it reflects maximum amount of energy, and then it is just because of water also contains vegetal matter. It is 1.4 and 1.9 and then 2.4 micrometer wavelength regions, and there are certain valleys and peaks are there. So these are all some kind of reflectance mechanism through which you can able to. Yeah, percentage of reflectance. Percentage of reflectance. This is on the wavelength. On x-axis it is a wavelength. Yeah, I will go to the. This is all a few things about with regard to vegetation. Just a glimpse I was given, but it consumed half an hour time. Sorry, I may not able to show you all my PPTs because it is altogether 100 PPTs. You may feel bored also, I think, probably. But still, yeah, this is the GVMC, Greater Visakhapatnam Municipal Corporation, one of the second biggest municipal corporation in the state of Andhra Pradesh, next to Hyderabad. Okay, the beauty of Visakhapatnam is we have a reserved forest within the city jurisdiction, municipal jurisdiction. Okay, believe me, there are tigers are there. My home is somewhere here. Okay, there is a reserved forest. These thick reserved forests are there. Thick reserved forest. Believe me, often the cheetahs used to enter on the mainland in the urban agglomeration. People are scared about that. I have seen a cheetah was moving on a road. I was in the central government service. I used to move very often also. But I have not seen any cheetah. But I have seen in my own area where, of course, one of my co-participant is here. He is also from Visakhapatnam. Some cheetahs is moving. Believe me, why it is so happening? It is just because of encroaching in their domain and then subsequent it is. But the beauty of Visakhapatnam is there is a reserved forest is there within the municipal boundary. This is what exactly it is. You will not find, but of course Naidu is here, you will not find this much thick vegetation even in Arku also. Arku I used to go often, but it is all bodikondal, you know. The vegetation is remote simply. Whatsoever reason it is, and moreover that the hills are not supposed to it doesn't cover with the hydrophilic soil, therefore it is not also supporting any luxuriant deciduous forest. So there is a social forestry. It is just because for the coffee plantation or whatsoever it is. This is what exactly is, where we carried out a couple of vegetal characteristics with the help of satellite image. Now this is what exactly the NDVI, normalized difference vegetation indices. There are several algorithms are there. Several algorithms are there. See, it's all after all digital image processing. There are so many computer experts are there, DIP experts are there. They used to develop some kind of algorithms which automatically extract information related to vegetation. See this satellite image, this is a vegetation. False color composite and false color composite, vegetation is recorded with a red tone. That too dark red tone implies that it is a healthy vegetation. See this, the same area where the same one is also recorded with a white, dark white. That means healthy vegetation. We use the word vegetation vigor. What kind of vegetation vigor it is? A highly healthy vegetation it is there. And same area also you have the same white color signature. For other areas you can see this is urban built up area. City of the heart of the Visakhapatnam city is shown as a black color. Okay, this is what exactly is different. This is the major input for generating agriculture or forest, whatsoever it is, how much area is under agriculture, and then how much amount of output you will get it for this academic, for the financial year, for the Kharif or Rabi can also be easily assessed with the help of this algorithm. This is what exactly the case it is. You need not go for simply some kind of cumbersome process like digitization and then subsequently extraction of information and those kind of stuff. You can just leave it. There are certain automated extraction algorithms were already developed. If you just employ the particular algorithms, it automatically extracts that particular vegetation features, gives you the output. That's what exactly the case is. Now you see this grazing land, of course, very near my home, and this is Akkaipalayam highway. Naidu, is it right? Yeah, you can test it. This is what Hanumantuaka this thing, and then you can see here, of course, it is, the legend is not clear. Land is land cover, one kind of important parameter in remote sensing activities. And this is again, you see here, deciduous forest. This is all deciduous forest, and then this is also deciduous forest. And degraded forest, some amount of degradation is also noticed on the satellite images. And then a plantation, you can see here, there is a small plantation. Of course, Visakhapatnam is a beautiful place, of course. One has to see that. Okay. And then this is, what is this name, sir? On the back side of this Yaradakonda. Yeah, there is a beautiful plantation is there. You can see that on the satellite image also. Now, yeah, no, this is the one. Yeah, this is the one. Yeah, plantation is this. This is the one. Yeah. No. This is the classified one. This is the classified one. Yeah. Then how satellite knows that this is a plantation and this is deciduous forest? Naming is not possible, na? It will record whatever it is there on the particular spot of point of time. It records this. It captures the data. That's all. It captures a photograph. That's all. And then this is a beautiful, of course, what it is, Rushikonda beach resorts. How they are encroaching, you see. This is what exactly the case it is. And then this is with regard to, in the GVMC, deciduous forest, this much square kilometer area, etc., is also given. Now this is what we did is, we just draped municipal ward boundary on the GVMC boundary. Okay, this boundary, GVMC boundary, na, is a 540 or 545 square kilometer area. On that, we draped the municipal ward boundary so that the ward 48 has highest vegetation, ward 13 has a lowest vegetation. Of course, this is what exactly the statistics. And then again, with highest vegetation, what are the species also? We were given, we took a help of a botanist and then some taxonomy, I think probably. He identified the plant species and other things, and then we took a photographs also. We substantiated with our studies also. This is how you can carry out with regard to this. And then for agricultural activity or for vegetation sustenance on this planet Earth, we need temperature, and then we need rainfall precipitation as well, without which you can't go for vegetation sustenance on this planet Earth. How it plays an important role, I just mentioned here, but we were not carried out any major activities with regard to these two parameters are concerned. Now, earlier we used to talk about remote sensing. In place of remote sensing, now hyperspectral remote sensing and then ultraspectral remote sensing. That means the few bands, that means tens of bands or less than 10 of band or 4 or 6 or 7 bands. In place of that, we are using hundreds of bands. Sometimes we are using thousands of bands also. What for this? It is simply an analog photography to digital photography, and then higher end of digital photography. It is what exactly it is. If I take a photography from a great height like a space and which gives maximum clarity with regard to vegetation, obviously it is a breakthrough. You need not go directly to the field. You can sit as well in your lab and then measure all kind of measurements and then understand the vegetal characteristics, etc. It is a 0.4 micrometer RBU satellite. It is 0.4 meter, 0.4 meter. That means 40 centimeters. 40 centimeters. No, there are so many softwares are there, so many, including outsourcing, including open source GIS also. Okay, ArcGIS is one software, Eridas Imagen is one software, Envy is another software, Ilvis is another software. There are so many, GeoMedia is another software. All these softwares have certain advantages and certain disadvantages. Certain softwares, they have a spectral library. For example, you go to Envy, there is a spectral library. For example, Deciduous Forest, if you click it on the particular one, it will show you the spectral reflectance curve also. Straight away you can make use in your theoretical presentations, etc. And similarly for Paddy or Bajra or whatsoever it is, you click it there, it will show you the spectral reflectance curve with regard to bandwidth also. So this is the beauty of this particular one. And then you go for some kind of algorithms development and all, and then extract some kind of information related to agriculture activities also. This is what exactly I want to showcase this one for your appreciation. See this, this is the one, of course I downloaded from the internet also, of course. This is burn index, you can assess it. Okay, splash and burn, zoom cultivation or Podu cultivation in our local name. Of course, Meghalaya is famous for this. Of course, some Podu cultivation is also there in our Visakhapatnam and Arakupadu areas also. This is a smoke intensity, you can identify visible band and very near infrared band and then shortwave infrared band where you cannot able to see this smoke. You can able to see only the forest blanks. These small dots are there now, white and then some kind of colors are there now. These are all burn areas. That's all. Now this is of course ISRO is doing a good work with regard to drought conditions of our country, entire country. Now coming to this GIS, what exactly geographic information system? See, nowadays we are all familiar with so many informatics, bioinformatics, hydroinformatics, IT, that is also informatics. Everything is an informatics. What exactly it implies that you have to collect some data, put into a particular software. When this particular software exclusively talking about biology, it's a bioinformatics. If the same software talking about, say, other software talking about is good for some water applications, it is a hydroinformatics. Similarly, geoinformatics, we use the word geoinformatics, is substitute for or synonymous word to the geographic information system. GIS is so popular in the world. It is a map making. That map making is a dynamic map making, not static mapping. It is like not like ICRISAT, the same figure that you have drawn. Okay, you as and when you want to change the logo of the ICRISAT, you just go and crop it, and whatsoever way you can tailor it, and then make it in a new presentation without much time. This is what exactly the added advantage. This is good not only for natural resources like vegetation and then forests, etc., agriculture. This is also good for social or administrative activities. This beauty of this particular software is it gives some kind of solution. This is what exactly the added advantage of this. Okay. Now when you use the word geographic, this is a map. Map contains some kind of latitude and longitude, 00 and 100 indicates that real world. I will show you that also next in the next slide. This is tagged with a particular information. If you digitize this, the polygon 1 I digitized as a ICRISAT. In the polygon 1, automatically ID hash ID is ID and name is ICRISAT. And then what you can add, go on add Bajra or whatsoever it is, whatever way you can add it. As and when you select this ID, it will be automatically highlighted. As and when you select this, the table also will be highlighted. You can go for some kind of manipulations, and then some kind of this thing is also possible. And then I will show you some of this thing. And then what makes data spatial is just because it is a dynamic map, not like a static map. That is the reason why. And of course, need of GIS, microscope is to biologists, and then GIS to geographic analysis. Geographic analysis doesn't mean that it is only talking about geography. It's a virtual real world. You can solve so many real world problems. This is what exactly the beauty of this particular technology. And then managing resources, provide insight to issues. For example, where pest is a recurring problem for a particular agricultural activity in a particular area, you try to map the particular area and then put it in GIS, and then the system itself find the solution. You need not find any solution. This is the beauty of this particular software. Why we use GIS? Dynamic digital map versus paper map. See, paper map, when you go for scanning and all those kind of things, it's a cumbersome process. But digital map, you can send it directly to your friend who is there in America. So you can also go for some kind of updation, and editing is possible. And excellent visual digital presentation is possible. And then rapid data processing, low cost data per unit, and then complex spatial analysis is also possible. And then repetitive processing of data is possible, dynamic visualization is also possible. So finally you have to provide, sometimes even with the 3D also is possible. Then this, I will just skip all these kind of things. I will just show you this. For this is what exactly this is the real world, and this is the vector, and this is the vector, and then these are the two software GIS data models are there, and then raster and then vector, raster and then vector. This is the real world, and then this is a discrete points, that means point, line and polygon, and then same one is depicted on this particular grid. It is a pixel. Sometimes we use the word tessellation, and then regular tessellation and irregular tessellation, of course, and then it is a pixel. That means a point is shown as a 0 dimension, and then line is shown as a single dimension. For example, an area is shown as a 2 dimension, for example. When there is a elevation, it is a 3 dimension, for example. Sometimes we use the word 4th dimension. It also talks about time. Yeah, this is the one. You see here, I just skip all these kind of things because you don't have time. Yeah. Layers. Now, this is the real world. Okay. The earth is sometimes appears to be like this. There are buildings, roads, etc. are there. I want to extract from the satellite image. Believe me, this is the satellite image. Assume like that. And then from the satellite image, you can extract roads, buildings, and then customers, etc. So what kind of customers is just only extracted figure from the satellite internet. And then you can work for these layers. You have to stack these layers for in the GIS analysis, so that for a particular application is concerned is possible. Now, linking of the polygons. Now, with the help of non-spatial data, this is a non-spatial data. How bank your account and railway information is there, in the similar way, is non-spatial data is also there. You can digitize a ICRISAT area, and then ICRISAT area administrative buildings, and then research buildings, hostels, and then mess. Everything you can just give some small polygons, and then there is a non-spatial data is also there. That means the Chukka Srinivas is already mentioned that relational database. Relational database means it's just simply a table, rows and columns, wherein you can mention a table hostel, and then other things also is possible. You go on add as long as some kind of extra information is necessary to input in the particular one, you go on add those kind of things also. Linking with these kind of things. Advantages and DBMS, database management system, of course, you're all familiar with this kind of thing. And then attribute data, this is what exactly the case it is. And then hierarchical models, there are certain things are there, of course. And then these are all some, of course, I didn't have time. Srinivas is asking me to stop. So I just run through all these kind of things, you just see. And then querying of GIS data is also possible. That means both spatial and non-spatial. That means with using your map also you can go for overlaying techniques. Using your non-spatial data, that means simply a relation database also, you can go for some kind of query. So it also tags its corresponding layer and gives you the output, new output. So that means the software itself is taking some kind of decision. This is what I get the added advantage. Now this is, we reached up to this level, believe me, this is the what. Using the satellite images, you need not go directly to this. Height also can be measured on the basis of shadow sometimes. With the help of aerial photographs, you can measure the height of the building also, height of the tower also. Now with the nowadays LiDAR technology is there, so it's good for measurement of third dimension, and you can also develop like this. and if at all you are interested to know about the subsurface conditions also is possible. Now anyway, this is a case study, second case study. Probably shall I stop it? What shall I do? Yeah. Well, this is a clean development mechanism. You're all familiar with this. The clean development mechanism, basically the objective is carbon sink. What the carbon sink? A tree is a carbon sink. It absorbs carbon dioxide in the process of photosynthesis, and over a period of time, the canopy and then girth of the plant will be grows. So as it is a bigger girth and then canopy is big, it implies that it absorbed several tons of carbon dioxide. When you remove vegetation, when you release more carbon dioxide into the atmosphere, it leads to global warming. But the World Bank is sanctioned this. There are Annexure 1 countries and Annexure 2 countries, where the industrialized countries, they are releasing obnoxious gases into the atmosphere, which is the reason for global warming. Third world countries like India and then African countries, they are poor, they are removing the vegetation. So then these countries are funding to these third world countries in order to improve vegetation so that the ecological parameters comes to the normal state, and then it will address the global issue like global warming. So we carried out a small work for Bamini Mandal. They were given baseline map of 1980 satellite image is a baseline map, and then reset satellite data. Now the beauty of this, if I identify a person who is willing to enter in this particular clean development mechanism, his area should not be sacrificed for food production. Only the bund area can be used for some kind of plantation, like teak or any timber wood. Timber wood is a strong wood, na? It absorbs more carbon dioxide. So we just support that kind of wood to be grown only on the bund areas rather than the plain areas. Because if at all it grows for a total 10 acres or 20 acres, it affects to the food production. Again, it's starvation problem. So that should not be the case. But it has to improve greenery and how much carbon credits he is eligible by growing that kind of plantation on his bund areas. Also he gets some kind of incentive per year through World Bank. There is no middleman involvement in this particular activity. So data used, of course, 1990 satellite data, January data, baseline is 1989 December 31st. It is so difficult to get exactly like a 1989 December satellite data. That is the reason why we got satellite data of 1990 January 6th probably. And then I carried out the work in the year 2011, and then I collected that satellite data of January 2011, and then Google Map, GPS, everything we used. This is the procedure we adopted, and this is a small patch. This is a mosaic of the different satellite images, and then this is IRS P6 satellite image of 2011, and then 1990 Landsat satellite image, and then this is the topo sheet. The first one is the topo sheet, and then second one is the Landsat image of 1990. You see the variation. Vegetation is more here, vegetation is also more here, but other areas you see here, there is a less vegetation is there, and then more area occupied. Vegetation was removed more in this particular area. See here, there is a vegetation is there. That means greenery is there by that time in the year 1990, and here there is no vegetation at all. But the land should be consistently from 1990 to till now should be fallow, should be unproductive. Then only that kind of lands are to be identified, and that lands are to be makes as a part in the particular process, and then the particular persons are eligible to get some kind of carbon credits through World Bank. This is another geometric. This is all some kind of rectification processes and problems are there. WGS 84, then UTM projections, and then geographic lat-long projections, etc. are there. Those kind of problems we already faced, and this is a methodology too. And then we identified fallow lands for a time periods, and then this is what I. Now, how do I identify a particular persons who are eligible to be a part in the particular program? This is what exactly some Apparao or Subbarao or Venkatrao or whatsoever it is. How they are eligible? That's what exactly it is. So there is a cadastral map. That means a revenue map. So we rectified the revenue map with the help of this topo sheets and then draped over the satellite images also. I will show you that also. See this 1990 satellite image, this one, and then 2011, this is the one, and if the same area, this is vacant, this is not vacant. See this, again the same is not vacant, and this is vacant, this is partially vacant, this is also vacant. You see this variation. So the growth pattern, this is what the red tone is not exactly dark red tone. It means that the small phenological growth, that means a small plant can't give a major reflectance character, can't be identified by the satellite. So that is the reason why it has been given a light dark red color rather than the other area where it is also recorded with a dark red tone. This is also same. You see here, this area is suitable because this is also covered with this is also partially covered with it, so people are eligible. So we generated eligible, not eligible simply. This is the person name, his ID or area in acres, and then eligible or not eligible, that's all. And then we were given by taking so many GPS readings and all those things. But the beauty of this one is directly linked to the World Bank. World Bank all of a sudden credit some amount in the name of some Apparao who owns 5 acres of land and covered some kind of vegetation on his bunds, and for which he may get 100 carbon credits. 100 carbon credits are open tradable credits it is. This year each credit is $10 for instance, 100 credits, $100. You will get a huge amount of money that will be converted into again Indian rupees. It is a very big incentive, but the incentive is not for an individual, it also addresses the global problem, that's the global warming it is. Thank you very much. If you have any small doubt.
Thank you, Professor Rao.
He was my, yeah. Yes, sir.
Yeah, your talk was very exhaustive.
Sir, because end of the day, no, sir.
No, but it was very exhaustive, very informative. Just to compliment, on the top of Google Map, now ISRO is also providing data through Bhuvan.
Bhuvan, yeah, exactly.
Sharing a lot of government data.
Yeah, it is true.
So, just for information of participants.
Yeah, Bhuvan, recently they brought this particular portal in ISRO website, wherein they covered some kind of information. But when it comes to the personal holding level, it will not address. So what we did is the local cadastral map, okay, that means personal holding property map. It doesn't have any coordinates, it doesn't have any scale also. It is something like a road map. How they drawn, only God only knows. So many others. But we use still that map for acquiring our property or registration of our property. But we eliminated that kind of issue problems and measured with the help of GPS and tracked the boundary of a particular individual holding and then calculated the area and then how much area is eligible for within the particular holding also we identified, and we have also taken him into confidence to be a part in the particular program, and then subsequently is eligible for carbon credits, etc. But the Bhuvan basically talks about the macro level. This will talks about micro level. This is what. Yeah, it is true that there is a program, basically Sam Pitroda and then former ISRO chairman, they're all planning to bring all this kind of information together. Instead of topo sheet talks about, satellite image talks about, and some other images talks about in a different manner with a different type of projections. But all this kind of information, if at all they put it into one particular map, then you can download that particular map. So how many people, the particular X person is having a 100 acres of land, 200 acres of land with different patches also you may have. But you can track those kind of things also with the help of, when all this information put together, brings to the common coordination and then put a perfect non-spatial data. Chukka Srinivas is also telling that database management has excellent added advantages. It will remove the redundancies. Okay, manual record, always you go on manual record, no? We must shift to the technology side. There is no other way around. If you still talk, maybe you may be right from your point of view, but we must shift to the technology side and then bring all the records to the database management and then go for this kind of algorithms and develop a data and then reduce the cumbersome process like field visit, etc. That is inevitable. That is inevitable. Yeah. See, we were interested only, in the GVM's area there is no agricultural except a few patches actually. That few patches, when we carried out the work, that few patches were also not gone for agricultural activity. Only it is a fallow land. Okay.
That can be done using different satellites altogether and different kind of statistical modeling. We need to see the ground truth, and then we need to compare the satellite image and some kind of statistical modeling. Then that can be done easily.
Yeah, you are absolutely right. But the question is, it's not that much easy. But you can easily say, see that particular this area is covered by paddy. Because if I am continuously working only on the paddy or bajra or jowar or whatsoever it is, it would be easy for me to identify the reflectance character and how it will be recorded in a satellite image. So I can easily say that by just looking at satellite image, this area is covered with a paddy or something like that. So on the basis of that, you also have some kind of common usage like Kharif will be in the months of this much and Rabi will be in the months of this much. We know that. So on that particular historical things also you can put it on the particular satellite image and then you can extract it. And then anyway, agricultural departments are also having their lot of data with them, and then you can make a set also.
Yeah, even Space Application Center Ahmedabad, they have a separated department division for the agriculture application using the remote sensing in the GS application. So they are doing a lot of work on this area what you are mentioning. We can even identify the crop type, maybe sesamum, maybe different. See, if you see the cropped area and see the vegetation reflectance, what he mentioned. So based on the reflectance and maybe based on the plant height, see in a certain point of time, one crop may be this much of height, another crop may be this much of height, and the vegetation reflectance is different. So, but we need to go for the ground truth. Without ground truth, we cannot get the accurate data results.
Yeah, exactly, he is right. But the question is, if at all ICRISAT is covered at least 500 acres, let us say. The entire ICRISAT is covered with bajra, let us say. So you take only one sample, record, not necessary to go for the entire 500 acres. So the remote sensing reduce the quantum of field work. Otherwise, what for remote sensing? Okay, this is what I get. You can extrapolate same value with the other area also. Okay, if you get a spectral reflectance, say for example 0.526, something like that, if the same value for the bajra in ICRISAT can also be extrapolated to Sikidrabad area. You got my point? So you need not go directly from here to there also, you go and take the measurements, etc. But field truth, field visits are must in order to reduce the some errors. That is must. Absolutely, that's what exactly the spectral signature of the particular vegetation. Not that crop area and production estimation, and then the starvations also, and then pest affected areas also can be easily assessed with the help of satellite images.
Sir,
yeah, yes, sir.
There is a difference in the date of transplanting and sowing of crop location to location. So there is always a difference in the height and all these things and the cropping pattern, because the land holding area in Indian condition is very small. So sometimes what happened that this image give us a misleading information. so ground level survey is the only and only way,
yes,
as far as the field crops are concerned.
Yeah.
For forest it is okay, but for field crop.
See, you are 100% right, sir. When I appeared for associate professor interview, one of my vice chancellor, he is a very intelligent man. He may become as a Reserve Bank director also soon. And then as a field expert in my domain, I just mentioned that my subject is fantastic and it is up to date and it is accurate also. Then he raised a question, Rao, how you say that there is a very big tree under which generally in our country people used to go for agricultural activity. Can your technology able to identify it? It's a little bit difficult. It will be difficult. So that is the reason why Srinivas is telling some field checks are necessary. Without field checking, if you can make it data is 100% right, nobody will not believe it. So for all remote sensing, within bracket we use the word with limited field checks. That is a common procedure. We have to mention, otherwise people put a questions.
Okay, one more input.
Sir.
With recent RSAT satellite,
Huh.
you will have 30-meter resolution now.
Yeah, that is a microwave, sir. That is microwave.
But still, you know, you can get a lot of ground level data now.
Yeah, see, microwave is basically good for certain applications. Certain applications. There are certain WIPs, advanced WIPs, AVHR data are good for vegetation applications. Okay, so people are using those kind of sensors only for agricultural activity. Yeah.
You talked about plants.
Okay.
So, is it safe for a human or animal?
Yeah, I will just give a small example for this. See, our skin is also a sensor. Okay. There is a fire, coal fire, let us say. In the beginning, when you lit the coal, then fire will not appear to our eye. But when you put your fingers in that, your finger skin sense that there is a heat in that. Got my point? So that is what a thermal infrared energy. The eye is opaque to the particular wavelength, whereas our skin sense that energy. Similarly, our eyes should not expose to the ultraviolet radiation. That is the reason all these spectacles UV guard. Okay, so that implies that UV radiation is there. A limited feeble energy is UV radiation is also there in the atmosphere. If at all it goes directly to our eye, it also damages our eye. Okay, so there is a filter like that. That energy can't be seen by our eye. No, not every. Yeah, you are right. With regard to physical characters are concerned, there is an amount of energy is reflecting even from the human bodies also. It is true. When the light is incident, see, there is a. You stop all the lights in this particular room, we can't able to see any individual. When there is a light, we can able to see. This is simple understanding. So that means some amount of energy is reflecting back even from the human bodies also.
Finally, my statement is that
Sir.
Satellites failed to find the Laden and field workers find the Laden.
Okay.
It's true. True fact.
That's it. No, I couldn't get your point, please. Please, sir, repeat once again. I didn't get your point.
Satellite could not trace out Osama bin Laden, but the field workers find Osama bin Laden and at that place.
No. See, this is no. Absolutely, you're right. You're right. I am coming to that point also.
A combination of satellite as well as
No, sir. We should. No. I am coming to your point. When Rajasekhar Reddy chopper was crashed in our own state, and then ISRO people were so busy to track the satellite that is passing through the particular area, Nallamala Hills. Okay. So somehow they identified one European satellite and American satellite is moving through the particular area. And then they took a permission from European agency and then NASA also. And then they tracked that particular information also. Believe me, sir, when you travel by air, when there is a mist, when there is cloud, something like in a low depression area, can you able to see with our eye?
No.
Then how a sensor is possible, sir? Number one. Number two, when there is a microwave radar or a microwave sensor, then the waves are penetrates even through the clouds and record whatever the features are there in the particular area. And then the satellite also should have a sensor, otherwise it is not useful. This is what exactly some constraints. You see, remote sensing is not a panacea. It's not altogether. As you mentioned, it is a limited field checks are necessary. But the day will come, even you will eliminate that kind of limited field checks also, please. Try to understand this. Because when I was not able to identify my home on satellite image, but my home is also probably in this particular area when a Landsat satellite was launched. With the help of Google, I can able to identify it. And then in the future, probably, these kind of issues also will be addressed with the help of satellite images. This is what exactly, and then the software otherwise. This is not.
Thank you, Professor Rao, for extensive and informative presentation. Thank you very much to you all to spend full day today. Even we crossed 5 o'clock even. And tomorrow we'll meet at 8:30 and we'll have the applications of ICT 4D and other sessions. Thank you very much.
Thank you, sir. Thank you.